Hi friends, today we are going to discuss on factors affecting solubility of a drug. This is actually a basic for entire pharmaceutics subject, but we are discussing here particularly for the third semester physical pharmaceutics 1. So, first of all, we want to know what is solubility. So, if you are telling that particle is having good solubility, we are actually telling the indirectly about the interaction between the particle of the solute and the solvent. So, in a solution, solute and solvent are the two parts, and that interaction we are calling it as solubility. So, this solubility depend on the nature of the solute as well as the composition of the solvent. So we have to study in particularly which are the solute related factors like size, shape, surface area, molecular size, what is the physical characteristic of the solute. And secondly, we have to discuss about the solvent related factors like what is the nature of the solvent, polarity, volume, pKa as well as heat of fusion, and environmental related factors like temperature, pressure and pH of the solution. First of all, we are telling about mainly the factor is molecular size. As we know, if the particle size or molecular size is high like that, that is having less solubility. So, how to decrease the particle size? If the particle size is getting decreased like that, what happened? We can tell like that it will cause increase in surface area. If it is more increase in surface area, more contact area is there, so thereby solubility increases. Second factor is particle size, shape and surface area. So in that case you have to think about this equation. Log S by S0 is equal to VR by 2.303 RT by gamma, where gamma is the surface tension. So it is simply an expression to show the relationship. If the particle size is smaller, surface area to volume ratio increases. So what we need, the particle size have to get reduced, and larger surface area is there, means if the particle size is less like that, more surface area is there, so greater what happen, greater interaction will happen with the solvent. So whatever equation if you are supposed to write, you are supposed to write what are the parameters involving in that. Next one, what are the other presence of substances in the solution. For example, if you are adding an electrolyte, so how the electrolyte affect the solubility of non-electrolyte. For example, if you are adding ammonium sulfate, so if you are adding an ammonium sulfate, it reduces the solubility of proteins. So next case is if you are adding a non-electrolyte on solubility. So how it affect? It decreases with the, means solubility decreases with the non-electrolytes. Third thing we are telling about common ion effect. Common ion effect means, for example, if you are adding silver chloride in water to a solution having sodium chloride solution. So the common ion is what? Chloride. So what happens is that if you are adding like that, solubility decreased by the presence of the second solute, that is the common ion effect in relation to solubility. Next thing we want to think about the physical state of the solute. So in the first unit solubility and next unit states of matter, we are studying about different states of a particle. So physical state means the drug, if it is available in more than one form, we are calling it as what? Polymorph. So polymorph itself, that is available in unstable, metastable, unstable like that. So the metastable polymorph having higher energy state, but it is having lower melting point. But among the different polymorph, it is metastable having higher aqueous solubility. So you can write with the help of an example. Riboflavin, we know it is a vitamin. It exists in 5 polymorphic form. And among this 5 polymorphic form, the form 3 is 20 times more water soluble. So we have to choose this riboflavin 3 form if we want to increase the solubility. Next form we are telling about amorphous and crystalline, right? So in the amorphous substance, it is having greater aqueous solubility due to the energy required than the Next form. Then next one is hydrate and solvate. Hydrate means if the water, if you are using as a solvent, in that case we are calling it as hydrate. Solvate means it is a crystalline solid adduct containing either stoichiometric or non-stoichiometric amount of a solvent incorporated within the crystal structure. If water we are using, the solvate as already told like that, hydrate. Next factor is co-solvent and solubility. How it affect means mixture of a miscible solvent. If you are adding to increase the solubility of a poorly aqueous soluble drug, such solvent we are calling it as co-solvent. So actually, what is the purpose of co-solvent? Co-solvent improve the solubility of the drug as well as volatile constituent. So examples are ethanol, propylene glycol, PEG 300 like that. Next one is the environmental related factors. If you are increasing the temperature, how it affects. So as we know, heat is required to break the bond holding the molecule in the solvent. At the same time, the heat is given off also during the formation of a new solvent. So if you are telling a relation of temperature, we are supposed to draw one graph. So what we want to draw, we have to plot the solubility of the solute on the y-axis and temperature on x-axis. So we will get two types of solubility curve. One is continuous curve like the first one, and second one is discontinuous curve. And the continuous curve is normally come coming in the case like NaNO3K, NO3K, Cl, sodium chloride, etc. But discontinuous solubility curve are mostly given by the hydrated form of the thing. So you can see the thing like calcium chloride, 6 molecules of water having a temperature of around 20. If it is means if you are giving more heat like that, what happen? It become first to 4 molecules of water, then to 2 molecules. So we can see what instead of a continuous peak, we can see discontinuous solubility curve in case of hydrated form. So in continuous solubility curve, we can tell like that no sharp breaks are there, and the solubility curve showing the representation of changes of direction. Next factor is vapor pressure. So we want to think about this vapor pressure in case of gaseous solute. If you are increasing the pressure, it will increase the solubility. Decrease in pressure, it will result in decrease in solubility. But in case of solid and liquid solute, changes in pressure have no practical effect on the solubility. Next factor is effect of pH on solubility. So when pH we are adjusting, at that time what happens is that unionized molecules are produced in a sufficient concentration to exceed the solubility. So what happens as a result like that, it will result in precipitation. Next one is molecular structure. So if we are changing means if you are slightly changing the molecular structure, it may result in changes in the solubility. For example, if you are using an ester form of a drug instead of a normal drug, it will result in decrease in solubility. And if you are converting an acid into its corresponding salt, what happens? The dissolution increases because of the interaction, thereby result in the solubility. Sometimes if we are converting into another form like that, we can mask the taste. For that example is chloramphenicol. Actually, if it is available as such chloramphenicol, it is bitter in taste. If we are converting to chloramphenicol palmitate, it becomes tasteless. So these are the main factors you are supposed to write if you are getting a question out, factors affecting solubility. Hope this video will be useful for you. If you like the video, please share to your friends. Thank you for watching.